In this example, we want to find the derivative of dy dx for the equation e to the xy minus 4xy cubed equals 3x squared. The setup here is basically leading us towards doing this via an implicit differentiation sort of method. So we take the derivative of the entire equation and then compute what we would get. So for e to the xy, we know the derivative of e to the u is just e to the u times the derivative of the inside. So this will give us an e to the xy times the derivative of xy minus, this next part is just a product rule. So I'll see 4y cubed and minus 4x times 3y squared dy dx, where this 3y squared comes from differentiating the y cubed term, differentiate the x for the first term there. And the right-hand side is the 3x squared, that just goes to 6x. Now we know the derivative of xy we do by the product rule. So I'll see to e to the xy times y, differentiating the x, and then plus x dy dx when I differentiate the y. The rest remains the same. And now before I try to solve it, I want to distribute that e to the xy to the two terms inside. So I'll see the following. Y times e to the xy plus x e to the xy dy dx minus 4y cubed minus 12xy squared dy dx equals 6x. And now I can try to solve for dy dx. So I want to have all terms with dy dx on one side of the equation and everything else on the other side. So that means I should move these two terms over to the right, giving me x e to the xy dy dx minus 12xy squared dy dx equals 6x plus 4y cubed minus y e to the xy. I can then factor the left-hand side of this by pulling a dy dx out of each term, and the rest remains the same. And I can get my final answer by dividing both sides by this thing that multiplies dy dx over here to give me that dy dx equals 6x plus 4y cubed minus y e to the xy divided by x e to the xy minus 12xy squared. And that's how you work out the answer to this implicit differentiation problem.